What I want to look at here in this video is calculating the determinant of a 3 by 3 matrix. Now, in order to do this, what we're essentially going to do is take a 3 by 3 matrix and expand it along a row and column such that we can eliminate that row and column from our pattern and then create a 2 by 2 matrix with the elements that are left over and apply calculating the determinant of a 2 by 2 matrix in order to be able to then apply this to a scenario where we'll end up with 3 2 by 2 determinants which can then be combined into one value to create an overall determinant of a 3 by 3 matrix. Now the idea behind this comes from creating a 3 by 3 system of equations. Ax plus by plus cz equals r, dx plus ey plus fz equals s, and gx plus hy plus iz equals t. Now what we can do is set up that system in terms of a matrix for the left hand side and then use this to rewrite x, y and z's in the format where they involve just the a, b, c, d, e, f, g, h, i, r, s, t. So rewrite them in terms of those variables. We can then work that through, gather the various elements together and equate them, and then come up with a formula for the determinant of a 3 by 3 matrix. Now it's a lot of work to go through that, a lot of letters involved and a lot of characters. However, there is a very straightforward way to remember this methodology and a very straightforward way to do it, which is where my main focus is going to lie in this video. We want to know how to do it and the method to do it. That's the key thing for us right now. So let's imagine we consider a generic matrix A given in this format here. Now what we have to do is define two new elements, if you like, which are going to come in useful and handy when looking at the formula for the determinant of our 3 by 3 matrix. The first of these is the minor of entry aij, which we're going to denote by mij. Now what this is this is the value of the determinant resulting from deleting a row I and a column j from our 3 by 3 matrix and then making a 2 by 2 matrix with the values that are left over. So for example, M21, so my minor entry of 21, would be the minor entry here. If I delete the column and the row that it is on, my minor entry would be the determinant here of a 2 by 2 matrix made with the elements that are left over. So A12, A13 on the top row, and then A32 and A33 on the bottom row. And we know how to calculate that, it's just this formula here. So that's what's going to be called our minor of entry. What we then want is the signed minor or cofactor of entry aij. Now this is denoted by capital A of ij, and this is determined by this formula here. Now it brings in the minor element, the mij. What it also does is it starts to look at the sign involved. So it would be -1 to the power of I plus j. If you think back to when we were solving equations, solving systems of equation, and we were looking at rewriting vectors in terms of a third vector when we do the cross product, we had our I, our j and our k in the top row, and I told you that expanding along I gave us a plus, expanding along j gave us a minus, and expanding along k gave us a plus to start with. This follows from the logic of that, and using this we can determine the sign of any element within here which can then be associated with the minor element of that entry. Now using this we can express the determinant in one of three ways. So what we can do is we can express it as the determinant with relation to entry 11 A11 plus entry 12 A12 plus entry 13 A13. So what that means is I'm going along the top row and I'm expanding each matrix by deleting columns in turn and creating a set of 2 by 2 matrices there. The second one I do the same thing, but I go along the middle row and then delete each column in turn to get a set of 3 2 by 2 matrices which I can then use to calculate my determinant. Or I go along the bottom row and do the exact same thing. So look at each column, delete it, create a set of 2 by 2 matrices with what's left over, and then use them to calculate the overall determinant of my 3 by 3 matrix. Now, one hint I'm going to tell you is that you need to pick a row which has zeros in it. So if there are zeros available, pick that row, because what that does is it cuts down on the deal of work we're going to have to do. Now, that's a lot of logic and a lot of wee formulae you need to know. However, the best way to see it in practice is to physically do a couple of examples. So I'm going to show you one where I'm going to break it down into minor elements and cofactors, but then I'm going to give you a question where it's just calculate a determinant and show you the steps involved. So the first question is, let's imagine I've got a matrix A given by that there. So the first thing I want to do is calculate the minor 2, 3 and then the cofactor A, 2, 3. So let's imagine I want to calculate the minor element M23. So what that means is it's the second row, third column. So what I'm going to do is if I go to the second row and third column, I then eliminate the column and the row associated with that. I can then say that M23 is equal to the wee determinant given of 1, 2, 2, 1, which in this case we know is 1 times 1, take away 2 times 2, which is 1 take away 4, which is negative 3. What I can then say is my cofactor, A23, what that's given by is negative 1 to the I plus j. Well, in this case, I is 2, j is 3. So negative 1 to the power of 2 plus 3 times m, 2, 3. Now, negative 1 to the 2 plus 3, that's negative 1 to the power of 5. It's then times this m23. So the m23, which is given by this, times the negative 3 there. So what I now have to do is determine what this negative 1 to the 5 is. So I know that negative 1 squared is 1. Negative 1 cubed is negative 1. So odd powers will give me a negative. Even powers will give me a positive. So this will be negative 1. So it's going to be negative 1 times negative 3, which is 3. So when asked to calculate minors or cofactors, these are the steps you have to take. Now this is then extended, and we could take this up to calculating the full determinant of a 3 by 3 matrix. What I'm going to do is I'm going to show you that now. So let's imagine I give you a 3 by 3 matrix like this, and I want you to evaluate the determinant. Now, as we said before, the determinant is calculated by taking an entry and then eliminating the row and column for that entry and multiplying it by the determinant of the 2 by 2 matrix that's left. Now, one thing I also want you to know, I mentioned before about the signs of each of the elements. So I mentioned before about the cofactors, where it depended upon the I plus j to give you whether it was negative 1 or 1. There is actually a quite easy and quick way to do that. If I imagine I write my matrix and I do the top row as plus minus plus, second row is minus plus minus, and the third row is plus minus plus, what that means is whatever row I expand upon, it tells me there whether I'm adding or subtracting the elements as I go. So for example, if I expanded across the first row, I'd have plus A11 times its wee determinant, then take away A12 times its wee determinant, then plus A13 times its wee determinant. If I expanded across the second row, I'd have minus A21 times its wee determinant, plus A22 times its wee determinant, and then minus A23 times its wee determinant. So it helps me to remember that. So that wee matrix there, actually, if you write it out, could help you when it comes to the signs. So let's label this as A, and let's look at calculating the determinant of that matrix A. So what I'm going to do is I'm going to expand it across the top row to start with. So what you do is you go along each entry in the top row, you eliminate the row and the column that it sits in. That will then give you a 2 by 2 matrix where you can calculate the determinant, but you multiply that 2 by 2 matrix by the entry itself. So if I go along the top row here, first entry is 2, and if I eliminate the column it's in, I'm left with this here. So it's going to be 2 times the determinant of -1, -5, 0, and 3. I then look at the signs and say, right, the next one's minus. So that's going to be take away the second column. So my first row, I'm now expanding along the second column. So if I then take that down there, I've got 0, -1, 0. And I look at then expanding. Well, what that means is I now have these two elements and these two elements left. So that's going to be -0 times the determinant of 3, -5, 0, 3. Table of values again in terms of signs. Third one's a plus, so I'm going to have plus that third one. And that element there is 1. So it's going to be plus 1 times my determinant. Now remember, the determinant in the 2 by 2 matrix we use to calculate that determinant, we eliminate the column it's in, and it's what's left. So it's going to be plus 1 times 3, -1, 0, 0. So I've gone along the whole row. I've then eliminated columns associated with that entry, and I've then calculated determinants of the 2 by 2 matrix with the values left. What I now have to do is physically do this calculation. Once I've done it, I'm laughing because I've got my determinant. So this one here, I'm going to get 2 times -1 times 3, take away 0 times -5. Now the good thing is, because this is -0 times something, that's just going to be -0. I don't even have to worry about calculating the determinant. Great. Then I'm going to have plus 1 times the determinant of this. So 3 times 0, take away -1 times 0. Lo and behold, that's also 0. So that goes, and I'm just left with this. So it's -1 times 3, so it's -3, so my determinant is -6. Now I could have gone along any row and expanded along that way. So for example, if I'd expanded along the second row here, so if we eliminate the row I've expanded upon there, and I then expand along the second row going here, I'd do the exact same set of steps. So I'd do my determinant of A equals, well, the first entry, 3, times the determinant is left by eliminating its column. So 0, 1, 0, 3. But looking at my table of signs, that entry is a minus. So that's going to be -3. Look at the table of signs, second one's a plus, so it's then going to be plus. Eliminate the column the second entry's in, so it's going to be plus -1 times the determinant of what's left. So you can imagine I delete that column. 2, 1, 0, 3 left. 2, 1, 0, 3. Last entry is going to be a minus, so it's then going to be take away. And again, we imagine we've got rid of that third column. It's then going to be take away -5 times the determinant of 2, 0, 0, 0. And then what you do is you calculate it out. Now if I calculate the determinant of that, what I end up getting is -3 times 0, -1 times 6, plus 5 times 0, which is -6. So lo and behold, my determinant is actually the exact same. If I were to do this example again on the bottom row, I would still find my determinant to be -6. So whatever row I expand along wouldn't matter. As long as I do my calculations correct, I'll still get the same answer. Now, if I were given this question from the very start, what I would have done is expanded along the bottom row. The reason being, these two values here are 0, which would mean my first two determinants would be multiplied by 0. So I wouldn't physically have to do the first two calculations, I would just have to do the final one. So there are times where we can kind of skip steps, and we've got little tricks like that we can use to tweak our questions and make sure we get the correct answers. When you're asked to evaluate the determinant, you don't have to do every single way. So you pick the way that works for you, you expand that way, you get the correct answer. As long as that's the final outcome, with your result being correct, you're laughing. It is an easy process to follow, we just need practice. Once we've got practice, you'll have nailed it.